finish 10.4, we did disjoint events, which, from the definition, were events that have no common outcomes. So remember, if we were looking at two events and we wanted A and B to happen, then we multiplied the probability of each. If we wanted A or B to happen, so we didn't care if A or B, we just took the probability of each and added them together. So anytime the problem tells you it wants both things to happen and you're multiplying, anytime we don't care or you're adding them together. Those are disjoint events or mutually exclusive. So we still had to do non-disjoint and complementary. So, non-disjoint events. Two events are two events that are overlapping if they have one or more outcomes in common. And so the examples have to do with cards, and we'll see what that looks like. But so this is going to be an OR event if it's the probability of A or B happening, but some of the outcomes overlap. So one of the examples talks about cards, and it wants to know if I pull a card, what's the probability of it being a queen or it being a black card? Now there's two black queens in the deck, right? So there's some overlap here. So we take the probability of the first event happening, and since it's an OR, we add them together with the probability of B. But then we have to subtract the probability of both of those things happening because and actually double counting because they overlap. So we have to subtract one of the overlaps. Okay? So those are non-disjoint. We also have complementary events, which we kind of talked about in the 10.3, but it's events that are opposite. So either it's going to rain or it's not going to rain. You're either male or you're female. It's true or false. You win or you lose. You know, it's either this one or it's that one. There's no in between. It's black and white. You don't have a gray area there. Okay, so those are complementary events. So to find the probability of complementary events, we take the probability of the event happening, the probability of the event not happening, and when you add them together, they should equal 1. Okay, always, always. If it's the probability of it's a 60% chance that it's going to rain, 6 out of 10, that means a 40% chance that it's not going to rain, right? So 6 plus 4 gives me 10 or 1. 0.6 plus 0.4 gives me, does that make sense?
Yeah.
Okay? Okay, I need to slow down. I know. So example 4. We have F choices here. So our situation is that we are drawing a card from an ordinary deck of cards. So how many cards are in an ordinary deck? 52 cards. Okay, so let's write that, 52 cards. Okay, so now these examples are actually going to be all different kinds of probability mixed up together. So we have to decide which one's which. So if I want to know what the probability of drawing a queen and a heart is, what do I have to do there?
Multiply.
We have to multiply, right? So what's the probability of drawing a queen? How many queens are in the deck? 4. So 4 out of 52. Now we want it to be a queen and we want it to be a heart. So how many hearts are in the deck? 13 out of 52. Okay, we can do a whole bunch of reducing here. 4 goes into 4 once, 4 goes into 52 13 times, and then I have 13 and 13 cancel each other out, right? So it's 1 over 52. And doesn't that make sense? How many queen of hearts are in the deck?
1.
Just 1, right? So we multiply those together and we should get 1 out of 52. Okay, what about B? Queen or a heart? Okay, it's addition. Is there any overlap there?
Yeah.
Yeah, there's an overlap. How many cards are a queen and a heart?
1.
1 card, right? There's 1 card that's the queen of hearts. But if we look for the probability of just queens, and then we add the probability of hearts, we're double counting the queen of hearts, right? So we have to subtract. So that's an example of a non-disjoint event. There's a little bit of overlap there. Does that make sense? Okay, so what's the probability of drawing a queen? 4 out of 4 out of 52, right? Okay, plus, because it's an or, what's the probability of drawing a heart? 13 out of 52. And then what's the overlap there? What's the probability of drawing the queen of hearts? 1 out of 52. So we have to subtract 1 out of 52.
If there's an overlap, you subtract.
If there's an overlap, you have to subtract the probability of both of them happening. Because here we're counting the queen of hearts once, right? And here we're counting the queen of hearts once. So we're actually counting the queen of hearts twice. So we have to subtract one of those counts. Does that make sense? Because you counted it twice. Okay, so let's just do this. All the denominators are the same. So that's 4 plus 13, which gives me 17 minus 1 is, so 16 out of 52. Does that reduce at all? Yeah, what goes into both of them? 4 goes into 16 4 times. 4 goes into 52, 13. So that is a probability of 4 out of 13.
We have to subtract the 1 because like we're doing the probability of all the queens and then all the hearts, but then there's a queen of hearts.
Right. So we have to subtract 1 because here we counted the queen of hearts, and here we counted the queen of hearts, which means we counted it twice. So we have to subtract 1 of those. Okay, so what about C, queen or a jack? What do we do there? The same as B? No, there's no overlap, right? They don't overlap. It's either a queen or it's a jack. So, but am I adding the probabilities or multiplying them? Adding, because it's an or. So what's the probability of a queen? 4 out of 52 plus the probability of a jack? 4 out of 52. So that gives me 8 out of 52. Yeah, reduced by 4. So 4 goes into 8 twice, and 4 goes into 52, 13. So 2 out of 13. Okay. D, 10 or a 9. Is there any overlap there?
No.
No, and the word that we are given is or. So is that addition or subtraction? Addition. So what's the probability of drawing a 10? How many 10s are in the deck? 4. So 4 out of 52 plus how many 9s? 4. So it would be the same thing. 8 over 52, which we already know is 2 out of 13. Okay. Still not too bad, right? Okay, what about the probability of drawing a 5 and a black card? Is there overlap there?
Yeah.
There is overlap there. Because there is a black 5. How many black 5s? 2 of them. The clubs and the spades, right? There's 2 black 5s in there. So we're actually double counting. So that's going to be a non-disjoint event. So how many 5s are there? Oh wait, hold on. Hold on. This sounds like a joint event, a disjoint. I got confused too. We want a 5 and a black card. So is it a non-disjoint?
No.
No, it's just a regular disjoint, right? Because we want it to be 5 and a black card. So what's the probability of drawing a 5?
2.
4 out of 52, right? The word is and here, not or.
So if it says or, then
If it says or and there's overlap, that's when we do this one. Okay, because the word is or. But the word here, even I got confused at first. The word here is and. Okay, so we're looking for a black 5. That's what we want. So the probability of drawing a 5 is 4 out of 52. What's the times? What's the probability of drawing a black card? 26 out of 52. Okay, let's reduce some first. 4 goes into 52, 13, so 1 over 13. And 26 over 52 is 1/2, right? Okay. So that's going to be multiplied straight across. 1 over 26. Okay, makes sense why that's not a non-disjoint event?
Yeah,
because it's an and. Okay, so make sure that you're reading the question carefully, otherwise you might make the same mistake that I did at first. Okay? Okay, so F is an example of a complementary event. We want not a club. Okay, so we are looking for a complementary event. The event is drawing a club plus the probability of not drawing a club, and they should equal 1, right? So how would I find the probability of not a club? We would just subtract, right? How many clubs are in the deck? 13. So if I don't want a club, how many cards are there to choose from?
39.
Yeah, 52 minus 13 gives me 39, right? So that would be 39 over 52, which equals, what reduces by both of those? What can we reduce? 3 goes into 39, but not 52. What goes into them? 13. 13 times 3 gives me 39. 13 goes into 52. 4. Does that make sense?
Yeah, because it's a lot.
Yeah. If we could have plugged it into this, probability of drawing a club plus the probability of not drawing a club, we should still get 1. We can just use our brains and do it without it. And doesn't that make sense? Because then we're looking for 3 out of the 4 suits.
Yeah.
So that is non-disjoint.